So the overall test, the total points is 76, and then I did a little curve to make the total 70. So if you see your test, you see the correction of the total points I'm taking counting. So the average is 50 out of 70, so it's around 71.4%. So the average is. Okay. And if you're interested in terms of the letter grade ABCD, because we're going to do this in the end when the whole semester is finished. If you want to see ABCD for this particular test, you can go to the syllabus. I have the intervals for the letter grades. So that's the first remark. Second one is, if you get your test, you add the points together and see if there's any arithmetic error. Okay. So if there's any error or mistake, or you don't agree with my grading, you want to argue with me, you want to discuss with the grading, you can come to me after class. Okay. So I want you to feel free to discuss your grading. Okay. So I'm open on that regard. So.
We were right on that problem.
200 points?
Yeah. What you get on that?
Okay. So. So if you have any question concerning your grade, okay, if you have any concerning about the grading, you can come to me afterwards. Okay. So any other question other than the grading system?
When's your office hours again?
Office hours from 4:30 to 5:30.
Today?
Yeah, today. Come to me after class.
Monday and Wednesday.
So come to me after.
So you want to
okay.
Oh, wait, Friday.
Any other questions? So.
I could have one question on the board. Is like the double integral of 2 times the radical of x over y.
Oh, no.
I have it right here. And it gives you like the integrals. The first part you have to figure out like which 2 are right, and then you have to solve for it.
Yeah.
Well, that's the wrong answer. I'm trying to like figure out how you can like separate it and do like each one.
Yeah, we can do this afterwards. I want to make a couple of announcements about this as well.
Okay.
So, you're going to be, I know if you don't get your test, you're going to be so unsettled for the whole semester. Okay, so me personally, I'm overall fine, I want to say, with the performance of the whole class. But individually, so here are 2 possibilities. If you feel like you can do better, I agree with you. Okay? If you feel like you could have done better, I totally agree with you. So this is only 1/3 of the semester. You still have plenty of chances to catch up. Okay? Especially, it may also be the case you have an integral mind rather than a derivative mind. So you are much better in the integral part, which we're going to discuss in the following. Or the other possibility is you feel very good about yourself for the first 1/3 of the semester. So this is another possibility. But keep in mind, this is still only 1/3 of the semester. There is a whole bunch of other stuff coming up. So for both of these 2 groups, you don't want to throw this test away. Okay? You don't want to have the mentality, I finished the first test, I don't have to worry about that ever again. You can only have this mentality when the whole semester is finished. Okay? You finish your final, you can forget everything about the calculus. I'm fine with that. But right now, absolutely you cannot throw this test away. So if you do not know how to do one problem, you absolutely have to know how to do this afterwards. So I will upload the answer keys on the Canvas. So you have to make sure you know every single one of the problems in this test. Okay? You cannot throw them away. And I have a couple of questions I want to discuss briefly. So the first one is number 2. So I have an equation z is equal to 8 minus 4x squared minus 2y squared. And I want to find the equation of the tangent plane. At 2, 1, and minus 10. Okay? So remember, we have two different formulas, which are essentially the same one for the tangent plane equation. All right, so if we have the equation defined by f x y z is equal to 0, and x0, y0, and z0. So this is what is the formula if the equation is defined by an implicit formula, right? So in this equation, I have a capital F with x, y, z, in which x, y are the independent variables, z is the dependent variable. So z is implicit here. All right, so we have a one formula for the equation of the tangent plane for this type of equation. Am I right? You still remember that? So we have fx multiplied by x minus x0 plus fy multiplied by y minus y0 plus fz multiplied by z minus z0 is equal to 0. Okay? So this is the equation of the tangent plane. And also, a very important fact about this equation, this formula, is that you're supposed to evaluate these partial derivatives at the base point x0, y0, and z0. Am I right? You're supposed to find the derivatives, the partial derivatives, and then evaluate at x0, y0, and z0. So basically, in the end, you're supposed to get three numbers for the three partial derivatives, and then you get an equation with only linear terms. All right? These are essentially numbers. So if you look at the equation of the tangent plane, if you see squares, you're definitely wrong. If you see square, if you have second order terms, they are not the equation of a plane. You have to evaluate and get numbers in there. Are with me? So this is a very common mistake. You have to evaluate and get a number. And also, I have said this in so many different places. If it is a plane, it has to be linear. All right, it has to be linear. So this is one type of the equation. The other one is in this form. So z is equal to fxy. So if the function is already explicit, we also have a formula to compute the equation of the tangent plane. It's going to be fx evaluate, let's say this is the evaluate at a, b. Okay? So fx evaluate at ab multiplied by x minus a plus fy evaluate at ab multiplied by y minus b, then plus the base point f of ab. All right? So this is the equation of the tangent plane if the function is explicit. All right? You still have to evaluate these partial derivatives at the base point AB. So basically, you compute the partial derivatives and then plug in these two numbers, evaluate, get a number here, so everything is going to be linear. All right? So when you are trying to find the equation of a plane, you have to make sure in the end there's no squares. Right? It has to be all linear terms. And also, this tangent plane, the equation of the tangent plane is exactly the linear approximation. All right? This is exactly the linear approximation. So in the formula, we use Lxy to linearly approximate the function around the base point AB. Okay? So about this equation, first of all, I have to compute the partial derivatives for this function. So I will just name this function as fxy. All right, so these computations are pretty straightforward. So if I compute fx, I'm getting minus 8x. Fy, I'm getting minus 4y. So evaluate at these two numbers, 2 and 1. All right? So fx at 2 and 1 is equal to minus 16. All right? And fy at 2 and 1 is equal to minus 4. So So I have to evaluate by plugging these values back into the partial derivatives. And then I use this equation. So the equation of the tangent plane is z equals minus 16x minus 2 plus minus 4 times y minus 1, then minus 10. This is going to be the equation of the tangent plane. All right? This is the value of AB. This is the partial derivative evaluated at AB. This is the other partial derivative evaluated at AB. Okay? If I look at this equation, I can simplify this, but no matter I simplify it or not, I can definitely make sure there's no squares in here, right? This is all linear, so it has to be at least in the correct direction, right? If you're getting a square in the end, definitely it's not the equation of the plane. So you can do our simplifications, minus 16x plus 32 minus 4y plus 4 minus 10, so I'm getting a minus 16x minus 4y plus 26. Okay, so that's the equation of the tangent plane. If you want, you can move all the variables on one side of the equation, or you can simply keep it in this form. So I'm looking at this equation, I feel at least safe. Questions? Yep. Oh, I will go over the last problem, but before that, I want to talk about number 5 as well. I want to talk about number 5 as well. Okay, so number 5, which is actually in the same direction as number 2. Okay, so I have a function f(x) y is equal to the square root of x squared plus y squared. Okay. Okay, so listen to me carefully. You can discuss with your peers afterwards. Okay, you can compare your grades, you can fight, you can discuss, you can do whatever you want. But in this class, let's focus on the problem first. Okay? So this is the function. I want to linearly approximate this function by using this formula. All right? By using this formula. A lot of people confused here about the rules of x, y, and AB. Okay? Here is the approximation. I want to approximate this function at the point 3, 4. All right? So 3, 4 is indeed the AB right here.
Yeah.
Right? So 3, 4 is the fixed point. That's the base point I want to approximate around. And then I want to use the approximation right here, arrow x, y, to approximate the function value at 2.9 and 4.2. So this is indeed a neighboring point to my base point 3, 4. I'm not going to plug in these two values into my function. Indeed, I'm going to use this base point to do a linear approximation. And then I'm going to plug in these two values for the linear function. Are you with me? Mm-hmm. So you have to be very clear about these 2 points. The first point is the base point you want to plug in for evaluating the partial derivatives. And the other one is the xy in the linear approximation. Are you with me? So this is indeed my AB. Like I said, all the approximations and computation are very straightforward. You just have to make sure which one you are going to apply, which one you're going to plug in. Okay? So as long as I fix their rules, the only thing I need to do is to do partial derivatives. And all of you are really good at taking partial derivatives. In the end, we have to gather things together to plugging it correctly. So fx as the partial derivative is x divided by square root of x squared plus y squared. So I need to evaluate fx at the point 3, 4. And this is nothing but a very simple fraction, 3 over 5. Right? And then I plug in 3, 4 for the partial derivative with respect to y. So x squared plus y squared. So my partial derivative evaluating at this point is nothing but 4 divided by 5. All right? So compute the partial derivatives, evaluating and get a number, and then you plug in. Okay? Then you plug in, then your computation will be pretty clear, and you don't need to mess up with all the square roots and everything. You can combine them together, but what I'm saying here is getting a number first and then plug in your linear approximation will make your function much more clean and clear. So error fx1, now forget about the function value at the base point. So if you want to write down this immediately, I want to have the function value at 3 and 4. And then plus fx evaluated ab or 3, 4 multiplied by x minus 3 plus fy evaluated at 3, 4 multiplied by 5, y minus 4. Okay? And I ask you to evaluate f of 3, 4. That's one easy point to grab, right? So evaluate the f of 3, 4. The only thing you need to do is just plug in 3 and 4 in this function. You get a f of 3, 4 is just equal to 5, right? So you easily can grab one point and live here. So this is equal to 5 plus 3 divided by 5 multiplied by x, which is 2.9 minus 3 plus 4 divided by 5 multiplied by 4.2 minus 4. Okay? And then all the computation and the calculation involving numbers are pretty simple. Right? So this is in the end getting 5.1 as the approximate value for square root of 2.9 squared plus 4.2 squared. Okay? So these computations are, as I said, very straightforward. Here is another hint I want to give you. Okay, here's another hint I want to give you. I see some people are doing very complicated computations, square root of 2.9 squared plus 4.2 squared, and then divide the whole thing by 2.9. This is not what I want you to be tested, right? I want to test you how to take the partial derivatives and how to use this to approximate functions in a correct way. I'm not testing you how to do squares of decimals correctly, okay? So you have to have this idea about what calculus rate is. Calculus rate is not testing you how well you know calculations involving thousands or thousands of decimals. Calculus is about how to use derivatives and integrals in a correct form, okay? The questions are usually about taking derivatives or taking integrals. But what derivatives are you taking and why are you taking this? Which is useful in the end? How do you use this? All right? So that's the key about calculus rate. So